for the latest update. Today we're gonna start with your physics for class 11 part 1. This is your class 13 and the unit which we have to start with is unit 2, that is unit and measurement. Lastly we had done your unit 1, which is your physical world. Now we go for it and we'll discuss here. We'll have start with the first question, that is being related to errors in the case of the measured quantity that is raised to the power. So there is a question, then we'll discuss about the significant figures, which has been the very important topic in terms of physics for your exam purpose, we can say. So here we go, and we deal with the question. So the question we have, this has been the question, that is the 12th question of the session. The question we have, the period of oscillation of a simple pendulum is t equals to 2 pi under root L by G. Measured value of L is 20.0 centimeter, known to 1 mm accuracy, and time 400 oscillations of the pendulum is found to be 90 seconds using a wristwatch of 1 second resolution. What is the accuracy and the determinations of G that we talk about it? So let's go for it. The period of oscillation of a simple pendulum is t equals to 2 pi under root L by G. Measured value of L is 20 centimeter. Known to 1 mm accuracy. And time for 100 oscillations. Of the pendulum is found to be 90 seconds using a wristwatch. Of 1 second resolution. What is the accuracy in the determination of the G? That we have. So we go for the solution. That is, we have to talk here. G equals to 4 pi square L upon T. So here T equals to T upon N and delta T equals to T upon N. Therefore, we can write it down delta T upon T equals to small t. So the errors is in the both L and T that are least, and delta G by G will the errors will write it down here, which is in the form delta G by G equals to delta L by L plus 2 delta T by T, which is equals to 0.1 upon 20.0 plus 2 1 upon 90, which will give you 0.027. So just I write it down here, 0.027. So thus the percentage error in G is, which is being 100 G by G equals to 100 delta L by L plus 2 into 100, which will give you 3%. So that we have as an answer. Now we'll discuss about the significant figures that we have. In terms of significant figures, here that has been as discussed above, every measurement involves error, and thus the result of the measurement that should be reported in a way that indicates the precision of measurement. Normally, the reported result of the measurement in a number that includes all digits in the number that are known and reliable that we have, plus the first digit that is uncertain, the reliable digit plus on the same we talk about it, that is being the first uncertain digit that are known as significant digit or the significant figures as well. In terms of it, if we say that the period of oscillation of a simple pendulum is 1.62 seconds, the digit 1 and 6 are the reliable and certain, while the digit 2 is uncertain. Thus, the measured value that has three significant figures, the length of an object reported after measurement, that to be 287.5 centimeter, that has four significant figures, where the digit 287 are certain and a 5 is uncertain. Clearly reporting the result of the measurement that includes more digit than digit significant digit is superfluous and also misleading, since it would give a wrong idea about the precision of the measurement as well. On the same vein, where we talk about it, that the rule of the determining the number significant figures that can be understood from the following example, like significant figures indicate, as already mentioned, that the precision of the measurement which depends on the least count of the measurement instrument. So in the same way, where a choice of change of different units that does not change the number of the significant digit or a figure in the measurement, just you have to write it on this. So let's go for it. A choice of change of different units does not change the number of significant digits or figures in a measurement. Yeah, this is important remark as Mark was following for the observation that will clear. Like for example, the length 2.308 centimeter has a 4 significant figures, but in different units, the same value that can be written is in the form of 0.02308 meter or 23.08 mm or 23080, that is be in the another form. So all these numbers have the same numbers of significant figures like digit 2308, namely for this shown as the location of the decimal point of no consequences that determine the number of the significant figures as well. And in the same way we talk about the examples that gives the following rules, and we'll go for it. So examples we have: the example gives the following rules. So where the first we have all the non-zero digits are significant. All the non-zero digit are significant. The second is all the zeros between two non-zero digits are significant no matter where the decimal point is, if at all. All the zeros between two non-zero digits are significant no matter where the decimal point is, if at all. So the third one we have here is if the number is less than 1, okay, and the zeros on the right of the decimal point but to the left of the first non-zero digit that are not significant. So we go for it. The third rule we have, example we can say following the rules: if the number is less than 1, the zeros in a number without a decimal point if the number is less than 1, the zeros that on the right of decimal point, but to the left of the first. 0 digit not significant. Okay. Here that is in 0.002308 where the underlying zeros are not significant here. So talking about for the another one which is the another here which is in the terminals or the trailing zeros in a number without a decimal point that are not significant. We talk about the same and let's go for it. So where we go for it, that is the terminal. The terminals or trailing zeros in a number without a decimal point are not significant. In the same way, here that we talk here, which is thus 123 meter is equals to 1 to 300 centimeter. 1 to 3, that is 1. We have 1,23,000 mm. That has a three significant figure that the trailing zeros being not significant. So however you can also see all the next observations as well. The next we have that the trailing zeros in a number with the decimal point are significant. The trailing in a number with a decimal point with a decimal point significant. So the numbers 3.500 or 0.06900 that have your four significant figures each. Now we talk for the second point that we have. This is for the first one. The second point for this that we have, there can be some confusions regarding the trailing zeros. Suppose a length of the reported that be 4.700 meter. It is evident that the zeros here are meant to convey the precisions and that the measurements are therefore the significant, and if these were not, it would be superfluous to written them explicitly. The reported measurement that would have been simply 4.7 meter. Now suppose we change units then. 4.700 meter is equals to 470 centimeter or 4700 mm or 0.0047 kilometers. Since the last number of that has been the trailing zeros in a number with no decimal, we would be conclude erroneously from the observation 1, and that we had done that the number of the two significant figures, while the fact that has been the significant figures and the measurement that change the unit, that cannot be the number of the significant figures will. So we go for the second, and then will be going for the third one, which is another here. And that to remove such ambiguities in determining the number of the significant figures, the best way is to report every measurement in scientific notation in the power of 10. So we go for it. To remove such ambiguities, determining the number of significant figures, the best way is to report even measurement in scientific notation. Notation, which is in the power of 10. Now we talk here for this, that is in this notation, every number that is expressed in the a into a की power b, where a is the number between 1 to 10 and b is the positive or negative exponent or power of 10. In order to get an approximate idea of the numbers, that we need round of the numbers a to 1 for a is less than equals to 5, and then the number that can be expressed approximately 10 to the power b, in which that has been expressed b of 10 in the order of magnitude. On a same way, we can say here, that is, for example, the diameter of the earth is 1.28 into 10 to the power 7 meter. Is of the order of 10 to the power 7 meter, that the order of the magnitude is 7. The diameter of an hydrogen atom is 1.06 into 10 to the power minus 10 meter. So in the order that 10 to the power minus 10 meter with the order of magnitude minus 10, thus the diameter of the earth is 17 order of magnitude larger than hydrogen atom, and it is often customary to write the decimal of the first digit. And now the confusion mentions that being above, which is being point 4, that is 4.700 meter, 4 point. Kilometer. The power of 10 is irrelevant, and that is determining the significant figures, how zeros appearing in the base of the number of the scientific notations that are significant, and each number in the case of 4 significant figure. Thus in the scientific irritation, no confusion arises about the trailing zeros in the base number of a, and they are always significant. Where in the fourth case, we can say here that the scientific notation that is an ideal for reporting the measurement, but this is not adopted. We use the rules adopted in the preceding examples. Like for this, we have For a number greater than 1, one without any decimal, the trailing zeros are not significant. The another we have for a number with a decimal, the trailing zeros are significant. Now here the another fifth we have that the digit 0 conventionally put the left of the decimal for a number less than 1, like 0.1250, so it's never significant. How the zeros at the end of the such number and that are significant in the measurement. The only thing we can see here which has been the multiplying or dividing the factor, which are neither rounded, and number on the number representing the measurement values for the exact and have an infinite number of significant digits. For example, r equals to d by 2, which is s equals to 2 by r. The factor 2 is an exact number, and that can it returns as 2.0, 2.00 and 2.0000 as required. Similarly, in t equals to t by n, where n is an exact number here. Okay, so all these been happen here, and that is according to that we have to go for it. So the rest and we'll discuss in the next coming class, which is of course being important one, and you have to be focused because we'll discuss about rules for the arithmetic operation with the significant figures, as well as rounding of the uncertain digits as well. We'll discuss the numericals, rules for determining the uncertainty in the results of the arithmetic calculation, dimensions. Then we'll discuss dimensions of physical quantities, dimension formulas for the dimensional quantities that we discussed here. So here we go on our end here, and before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. In terms of physics part 1 for class 11, other than that we are dealing with for the chemistry for class 11 part 2, and we are dealing with quantitative aptitude, where we had started with your arithmetical ability. In that we had done many more, and we are dealing with the ER diagrams. We had done CNST, which has been the computer based numerical and statistical techniques. Some of the topics were left. In terms of physics part 1 for class 11, where we had done your chapter 1, which is physical world, which is what is physics, scopes and excitement of physics, technology and society, fundamental forces in nature of physical law. In chapter 2 we had started with units and measurement. In that we had completed your introduction, the international system of unit, measurement of length, measurement of mass, measurement of time, accuracy, precision of the instrument and the errors in the measurement, significant figures, dimensions of physical quantity, dimension formulas and the dimension equation, dimensional analysis and its application. In unit 3 we have to cover up the motion in a straight line, the fourth motion in a plane. Then next we talk about the motion, laws of motion. Unit 6 is work, energy and power. Unit 7 is the system of particles and rotational motion. Unit 8 is your gravitational. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box.